Hello. Today I'm going to talk about a new module right over here. It's called Affine, and it provides a scale and an offset for a CV, or really anything, I guess. And I'm going to walk through the schematic briefly. Starts with an input buffer. It's really only here because I had a spare op amp. And then we have a gain, which is a variable gain from 0 to 2, so you can attenuate or make something larger, I guess. And then we have an inverter here, because next is a switch, where we can choose whether you want the inverted or uninverted, which we've got right here. And we also have down here a potentiometer for an offset. That's just from -12 to 12 for the full range. Those get summed together. There's a number of inversions here. You can work out for yourself exactly how many, but, well, I guess it's 1, 2, or 1, 2, 3 if you want it inverted. And then it goes to an output, but it also goes to this LED display, which is just 12 blue rectangular LEDs. And we can see if we mess with our offset, it's higher or lower, goes negative. It's showing up a little funny on the camera. It's kind of blown out in the overexposed in the, let's see if I can, yeah. Anyways, it looks a little dimmer in real life. But in any case, I'm using, for an LED driver, I was doing some complicated stuff with using some BJTs and so on, but then I realized that if I make the LEDs just a little bit dimmer, then the TL072 or 74 that I'm using everywhere else has enough drive to drive the LEDs. So what we're doing here is we're doing a voltage to current converter, because I found that when I just did voltage, there was this dead band right in the middle of at around 0 volts, where I would have to get a couple volts away from 0 volts before you saw anything on the display. Now this isn't perfect, because now there's absolutely no dead band. So if we go ahead and just disconnect our input there and watch as we decrease the offset, it goes down, and then immediately after that it goes into the negative. So, well, it's better than a big dead band, but I'd prefer to have a little bit of dead band there. In any case, the way I'm doing the LED display, once we get through the voltage to current converter, is I start here, and when we exceed the forward voltage of the LED, then we're going to get current flowing through this LED. Then we have another diode here, not an LED, just to get that voltage drop. So then when we exceed the voltage drop of this diode plus the LED, then we start getting some current flowing through that LED as well. And so on. And then there's 6 down here. And up here, it works the same way, except when we go negative, then we get current conducting through there, and when we go more negative, we get current conducting through there. And there's 6 up here and 6 down there. There's also some interesting stuff with the construction. I have a second one over here. And I wanted to go with a big fat switch for the invert, but I didn't want that switch to have the bushing sticking way up. So what I did is I actually soldered the switch to the back PCB and put a hole in the middle PCB. I'm gonna take this apart so we can see what's going on here a little closer. So here's the back PCB, and we have just 6 op amps, standard power, all that, and all those resistors. And then we have the switch soldered in here. Now the legs aren't quite long enough to reach. There's a little bit of a gap, but I just filled it with solder and it seems to be strong enough. I have some that are for wire wrap that extend about an inch out, and I could have used those, but those are on, off, on, and I decided that the on was more what I was wanting there. And then here on the other PCB, we have all those LEDs, and we have the diodes and the resistors packed in there as well. And originally I was doing this all SMT, but I figured out that I wasn't actually saving all that much space by going SMD, because when I put the diodes and resistors in vertically like this, they're not taking up any more space really. This hole in particular has to be big enough to fit this nut through. The first revision I did of this design, I made it more than big enough for the bushing, but not quite big enough for the nut, and that made it a real pain to assemble. And then I've got these standoffs just to keep it stable everywhere. And that's more or less it. Hope that was informative. If you have any questions, I'm happy to answer them. Otherwise, enjoy. So here I have two of my baby 8s, and it's all over the place, but I'm clocking one from the other. This one is running on its internal oscillator, which we can speed up, slow down, and all that. And then this one is using the same clock. And so this top one is controlling the pitch, and the bottom one is controlling the VCA and filter cutoff. The delay is coming from this build of Look Mum No Computers triple splashback. Here it is without any delay. I find it kind of crunchy, this delay. I think I'm going to build something a little cleaner, but I'm certainly happy to have a delay in my system. By momentarily stopping the advancement on the second one, I can adjust the rhythmic pattern independent. I can get them out of sync.